So we're back in Photonics 701, and today what we're going to do is go and visit AlexWinters in just a second. Alex has been working for about a month on a thing called an optical trap. An optical trap, it's like a set of tweezers that works so finely you can control DNA and put it where you want to put it. Let's go check it out. Hey! Hey, it's Alex. Hey, everybody. Hey, this is Alex's experiment that he's been working on for weeks and weeks. This is intense. Everybody, this is AlexWinters. He is going to take you through what this thing is, and you are going to learn quite a bit. It's amazing. Alex, take us away.
Okay, so everybody, for the first place you want to start when looking at the system that we have right here is the laser itself. We have up here the controller, which drives the entire thing. And down here you see we got a nice little house over the actual diode, which is the beginning of where the laser light is used. What we're using here is infrared laser light, so it's not actually able to be seen by the human eye, and it's actually very dangerous to be looked at by the human eye, so I have to wear glasses when it's on at all times. Now you see it runs through the optical fiber here into this port, and this is the beginning of the more, like, what the majority of my summer has been, which is the construction of this lens tube system, which allows for the trapping. Now you can see I have various things like right angle mirrors to reflect the beam here. Inside here we have what are called achromatic doublets, which are essentially just mirrors that we use to expand and then eventually later focus the beam down to a very minute point, like about the size of a micrometer. We have this right here. We have a camera, what's called a CCD camera, and this camera receives the light that comes from up here to essentially image what it is that we're going to be looking at. Now here we have our objective, which is once the laser light eventually travels like this through the system. Oh, yeah, once the laser light travels through the system, it gets focused onto the beads, and then when used properly, when the beads are within this laser light, they exhibit a unique sort of behavior, which you can measure the force when they're displaced. Now, in addition to a couple extra things, we have a quadrant detector here, which is used to measure exactly where the laser is and to make sure that it's moving perfectly through this system, so that there's no backscattering or dispersion or anything. And other than that, we have my stage where you put the beads on in here, and these are a bunch of controllers which, when they're fully operational, can be used to move this with a motor so that I don't actually have to crank anything, and also ensure that the beam is in the center, which, as you can see right now, it's off right now, but when it's on, if this green light is in the center, that means it's perfectly aligned. So that's essentially
cool.
It.
So what are we looking at here on the screen? You had a pretty interesting thing that was going on with the screen. That.
Oh well, first I guess you could show.
Oh wow! Look at this virtual control panel.
This is a graphical user interface for these controllers that I just showed, and as you can see, like, the laser's off right now, so this is kind of bugging out. But this, like, if I were to change how this is oriented up here, you would see this circle move in a corresponding direction. So that's another way how I can make sure that the laser's aligned. Then you can see, like, for each of the controllers, there's a corresponding graphical interface in which what I can do is what's called jog the piezo controller at a particular amount of voltage, which will move it a corresponding amount here. So it's good for, like, especially if you don't want to be getting infrared light in your eyes, you're sitting here as opposed to sitting like here, for example. So that's that. And then, as you can see here, it moved a little out of focus. There you go. What we have right now is a sample of beads, like little tiny 1 micrometer sized beads in a solution, which I inserted on a slide with a cover slip on top of it and 2 pieces of tape. So what I essentially did was I injected the microbeads. Siraj likes that. I injected the microbeads into a little channel of sorts, and once it dispersed across the channel, then what you can do is align this so that you're seeing half tape and half beads. Because then from there, you can like perfect how you're seeing the image and get everything working nice and good. It's been a great experience working on it.
Yeah, and Alex is one of the men that's been sharing his lab with us. Alex is an undergrad at BU. Just want to say a couple words about where you're from. What are you studying?
Okay, well, I'm from Flemington, New Jersey, which is on the west side of New Jersey, a little bit further north. I went to a school, 100 Central High School, a public school, sort of middle of the line, but it was all right. And I'm here at BU studying. I'm majoring in biomedical engineering. I'm minoring in electrical engineering, and I'm concentrating in nanotechnology. So I got a lot on my plate there, but it's like, yeah, I've really enjoyed my experience at BU. I've had a lot of great professors, and as you can see, it's like they really, if you involve yourself well, they give you opportunities like this. Like if you make enough friends, they will put you in a lab, and they'll make sure that you're doing something awesome, kind of like this.
Yeah.
So it's like it really pays to just go out there and just talk to people, you know.
You have any advice for high school kids with thinking about science, engineering, technology at all?
I mean, it's like I always tell people, it's like you have to love it. It's like you have to kind of channel your inner nerd sometimes. It's like if this stuff ceases to be cool to you, it's like, you know, you really shouldn't do it. It's like if you really have a love for like technology, and then eventually down the line using this technology to help people, because I mean, like that's been like the biggest driving factor for me, especially with my senior project now. It's like it's something that could eventually blossom into something that could help like tons and tons of people down the road. And you know, it's rewarding, right? You know, money's great, but it's also like knowing that you made a mark in the world with your time that you spent working. That's what it's all about, you know?
That's wonderful.